All right, today we're going to learn, do a little exploring with the triangle and something called a median. Okay, we've looked at bisectors so far. We've done perpendicular bisectors and angle bisectors. Today we're going to mess with something called a median. A median is a segment, okay, a segment that connects, a segment, that connects, this isn't the mathematical way of writing it, a segment that connects the midpoint of one side to the opposite vertex. Okay, so that is what a median is. So it's a segment that connects the midpoint of one side to the opposite vertex. So if I want to draw in a median here, first I need a midpoint. So we come over here and we want to do the midpoint or center. So let's do the midpoint of side A. So the midpoint of side A is D. So now if I create a segment that connects this midpoint to this opposite vertice, that is a median. So there is my median F. And let's go ahead and let's make our medians, and let's make them purple. Okay. All right, so there's my one median. So now if I'm going to do more medians, okay, to see if they're concurrent, let's see if these medians are concurrent. Okay, let's go ahead and make a conjecture. Pause a minute. Do we think they'll be concurrent? Okay, let's go and let's see. Hopefully you kind of visualized it in your head what they were going to look like. So let's go ahead and let's do the midpoints of the other side. So there's the midpoint of side B here, and there's the midpoint of side C. So now I need the segments that connect them. So let's connect E over here to B. Okay, and let's connect F to C. Well, looky there, it looks like my midpoint, my medians are concurrent. Okay, so my medians ended up being concurrent. Oh, undo, I don't want that point there. Redo. Okay, my medians ended up being concurrent. The point of concurrency here is point G. We actually have a name for the point of concurrency. The point of concurrency of the medians is called a centroid. So that's one of our new words for today. Okay, we call that point of concurrency a centroid. Okay. So we have that point of concurrency is the centroid. And what's interesting about this centroid is if we get some distances in here, let's do the lengths of each of these medians. So let's find the length of this median. Oh, oops, I didn't want the perimeter. Okay, distance from this median from A to D. A to D is 4.86. Let's go C to F, and then B to E. Okay, if you notice each of these medians, they're not congruent. Okay, so this one from C to F is 5.29. This one from A to D is 4.6, and this one from B to E is 4.2. Okay, so the medians themselves are not congruent. Okay, but I want to look at, let me mess with my medians a little bit. Okay, I'm just going to make them a little bigger just so we can see a little more, make it easier to see. Okay, what I want to look at is, do you see how now this median is divided into two pieces? We've got this piece from B to G, and then we've got this piece from G to E. So we have the big piece, B to G, and a little piece, G to E. Okay, and that's the same with this median here as well. We have from the big piece, A to G, but then we also have the little piece, G to D. And here, for this median right here, we have the big piece, C to G, and the little piece, G to F. Okay, I'm going to come in and I'm going to find the distance of the little piece in all of these. So I'm going to find the distance from G to E is 2. Okay, this distance from G to D is 2.1, and the distance from G to F is 2.7. Okay, and you might not notice the pattern, okay, but I want you to compare, to look at, because we got a lot of numbers here, is look at this entire median. This whole median from B to E is 6. If you look at this little piece from G to E, it's 2. If you notice, that's 1/3 of 6. 6 divided by 3 is 2. So this is 1/3, which means that B to G would have to be 2/3 of it. And we can go ahead and find that distance from B to G. Yep, and it is 2/3. Okay, so 2 of those thirds. And if you notice, the other ones are that way as well. Here, from C to F, if we're looking at this median right here, from C to F, okay, this median right here, C to F. Okay, if we're looking at that median, let's go ahead, I'm going to make that a different color so it stands out. Let's make it gray. This median from C to F. Okay, if you notice, the whole thing is 8.02, but if I come over here and take a third of that, let's take a third times that median, C to F, we get 2.67 right here, 2.67 right here, which guess what? That little piece is 2.67. So that's actually our big median theorem, okay? Our big, centroid theorem, is that it divides this centroid, cuts this median up into a piece that's 1/3 and a piece that's 2/3, okay? And that happens here for AD as well. This other median would be the exact same way. It cuts it up into a piece, this piece here, a piece that's 2/3 from A to G, the big piece, and a piece that's 1/3, the small piece, G to D. Okay, because 6.63, a third of that is 2.21. Okay, so that's our theorem.